Well, good evening, everyone. My name is Dr. Denver Fowler, and I serve as the Associate Dean of Graduate and Undergraduate Studies here at CSUB. It is my distinct honor and privilege to welcome all of you to the CSUB Grad Slam 2023. I do want to share that Alexandra Brown, unfortunately, was unable to be here today live. So Alexandra recorded her presentation. The title of her presentation is Seasonal Microplastic Pollution in Aquatic Environments and Biota Across Land Use Gradients. Her program is biology, and her advisor is Dr. Ray Manish.
Human trash pollution, as seen in Figure 1, is found in environments worldwide and is often primarily composed of plastics. Plastics differ from other litter types because they can persist in the environment for decades or centuries, not only as large visible litter, but also as smaller particles called microplastics. Microplastics are less than 5 millimeters in size, or about half the width of your pinky fingernail. Figure 2 shows examples of a microplastic fiber, fiber bundle, and fragment. Looking at Figure 3, we can see that microplastics are derived from two sources. Primary sources, which are plastics developed by industrial process, such as exfoliating microbeads, and secondary sources, which result from the fragmentation of large plastics like a bottle over time into smaller particles. Microplastics are easily dispersed across landscapes by wind or stormwater, with many particles eventually making their way into aquatic systems. They can be found throughout aquatic habitats, including in the water surface, column, sediments, and aquatic animals. These animals, such as fish, shellfish, and macroinvertebrates like insects, may passively ingest microplastics, which can accumulate in their digestive systems. Because these organisms are a part of food webs, they are consumed as prey by other animals, such as birds, larger fish, or crabs. Also in these food webs are humans, who rely on seafood as an important source of nutrition. But harvesting seafood items from environments that are polluted by microplastics moves plastics into the human diet. Because microplastics are often derived from urban sources with heavy plastic pollution, I decided to investigate if nearby land use, such as percent urban development compared to agriculture and forest, is linked to microplastic abundance in aquatic habitats and animals. My first research project, Figure 4, is at Lake Michigan, one of the North American Great Lakes. 8 rivers that differ in dominant land use and flow into the lake were sampled for river water, sediments, fish, and macroinvertebrates. The second project in Figure 5 features 15 California estuaries, which are the unique habitats linking freshwater and the ocean, and they will be sampled for shellfish and sediments. These estuary sites differ in dominant land use, as well as whether they are California marine protected areas, which are indicated in yellow. In both projects, I will extract and quantify microplastic abundance in habitat and animal samples. The abundance in animals is being tested to be linked to the abundance of microplastic in habitats, the surrounding dominant land use, and the food web position, such as predator or detritivore of the animals. And I expect that my findings will provide insight to potential mitigation strategies to reduce microplastics polluting aquatic ecosystems and being consumed by humans through seafood, which can help improve overall ecosystem and human health.
We have Ava Varastehjonoush, and her presentation is titled The Impact of Technology on Long-Term Care. Her program is Healthcare Administration, and her advisor is Dr. Anthony Polito.
As an international student, I've experienced a relocation or transition in my life. Let's talk about the life transition, about aging, that all of us in a normal life cycle will go through it. But did you know the United States is facing a big demographic shift, increasing 3% annually? What does it mean? The translation is in 2050, every day 10,000 individuals turn 65. It's a huge population, right? And that's why the World Health Organization, or WHO, considering this increasing age population, estimated a big shift in demand in long-term care and a need for reform in the healthcare system. That's where my research comes in. But what's the long-term care? Long-term care are activities undertaken by others to ensure people with ongoing loss maintain a level of functional ability consistent with their basic rights, freedom, and human dignity. In my research, after peer review of 230 resources, I chose content analysis as a qualitative method on 163 resources, and system theory, which is proper to analyze a multifaceted and complex system, which we see as a healthcare system, as a complex system, and liminality conceptual framework, which comes by the transition concept. But my findings: most of the challenges of the long-term care in the future comes under the regulatory effort challenges that are harmonizing the quality of care specs with affordability and residents' preference. Technology. The technology viewed as an augmentation, not a replacement to the workforce. So we need changes in roles. We need redesigning or designing new roles and continuous training by the healthcare leaders in future. Internet of Things, artificial intelligence, augmented reality, virtual reality, all of us not only help residents with the physical aspect of healthy aging, but also help them in psychological part, alleviation, the loneliness, and facilitate socialization. As we see my descriptive statistical analysis result in the right chart that shows the tendency of the residents to socialization. And the other actually finding is about the challenges of these beneficial side, that is about information security, is about privacy and ethical issues, that more research to the healthcare leaders in future are recommended in this field. Thank you.
All right, next up we have Isaac Owens. And the title of Isaac's presentation is, Does the River Continuum Concept Apply to an Elevation Gradient in an Arid Environment? His program is biology, and his advisor is Dr. Ray McNeish.
The river continuum concept is a pivotal guide in understanding terrestrial and aquatic connections throughout river systems and deciduous forests, all the way from the beginning of the river system, the headwaters, all the way down to the mouths of the river. Some of you guys may be asking yourselves, what is deciduous forest? It's basically just forests that contain trees that shed their leaves. So the river continuum concept predicts that the small headwaters will be colder and highly oxygenated due to the dense riparian forest that overreaches these small streams, creating a large amount of shade and reducing the amount of solar energy to be input into the stream. As you can see in pictures 1, plant materials such as leaves and sticks are expected to fall into these streams, creating a source of food and habitat for the aquatic food web. As these headwaters start to combine, the river channel starts to widen, allowing for more solar energy to be input into the stream, resulting in a higher temperature and allowing for more solar energy to be input into the stream, resulting in a higher temperature and allowing for more aquatic plant and algal growth. These shifts from stream to river ultimately affect the presence and abundance. My research is to investigate if the river continuum concept would apply to river systems in more arid environments at an elevational gradient. To investigate this research goal, I plan to investigate one river system, Tohoe Creek. I'll be collecting macroinvertebrates, as you can see in pictures 3. I'll be collecting plant materials such as leaves and sticks, plant woody debris. I'll be collecting water samples to test the amount of algae in each of these sites. I'll be testing the water parameters to see how much algae is in each of these sites. I'll also be calculating the density of the riparian forest. And some of the technology that I'll be using from these sites, you could see in pictures 4, 5, and 6. And these sites will vary from high mountainous elevations to low valley elevations, all throughout the river system. While I do not have data to share with you, because this research is still in preparation phase, I have 2 predictions, as you can see in figures number 7 and 8. One being that I predict that outside energy sources will be dominated in the headwaters, as energy sources will shift to inside the stream and lower valley elevations. I also predict that there will be a predictable macroinvertebrate community shift linked with these energy sources. I hope to be able to share with you the research and data that I collect in the future. Thank you.
Next up, we have Jonathan Juarez. The title of his presentation is Invasive Tree of Heaven Leaf decomposition in freshwater ecosystems, and impacts on macro and vertebrate communities. His program is biology, and his advisor is Dr. Ray Manish.
Freshwater habitats make up less than 1% of the total surface area of water on Earth. Human activities often impact these critical ecosystems, and one way is through the introduction of invasive plant species. Invasive plant species are defined as species that are introduced outside of their native habitats and are known to have significant and negative impacts on human and environmental health or the human economy. Tree leaf litter serves as a crucial connection between terrestrial and freshwater ecosystems, serving as energy and habitat resources to aquatic macroinvertebrates in these ecosystems. Common examples of aquatic macroinvertebrates include snails, dragonfly larvae, and crayfish. The invasive tree species Ailanthus altisma, also known as tree of heaven, and it's shown here in photo 1, is common throughout the Central Valley and along the Kern River. Tree of heaven is a fast-growing plant invader that outcompetes local native plant species. The goal of my research is to determine how aquatic macroinvertebrates that colonize leaf litter respond to the presence of the leaf litter from the invasive tree of heaven, and how this invasive species contributes to the energy available in freshwater habitats compared to native tree species. To address my research goals, I compared this invasive plant to 2 California native tree species, the London plane tree, shown in photo 2, and the Fremont cottonwood, shown in photo 3. I constructed leaf litter bags composed of mesh netting that encase the leaves, seen in photo 4, to create a native leaf, invasive leaf, and mixed leaf litter treatments. These litter bags were anchored in a pond on the CSUB campus, shown in photo 5. Subsets of these leaf packs were collected through time, which allowed me to determine how fast or slow all the leaves broke down over time and how macroinvertebrate communities interacting with these leaf species change over time. Results from this pilot study showed that invasive leaf packs decompose 6.5 times faster than the mixed leaf packs and 7.4 times faster than the native leaf packs. This is shown on the diagram labeled number 6. Percent abundance of macroinvertebrates was different among litter treatments. Looking at photo 7 there, tree of heaven leaves were dominated by aquatic worms and Daphnia, which is a type of freshwater crustacean, while the native leaf litter was dominated by amphipods, another crustacean, and chironomids, which is a type of fly insect. This pilot study will be redeployed at full scale, hopefully next month. It will include more collection events and the addition of a stream site along with this pond site. By understanding how invasive species affect freshwater habitats, we can better prioritize our efforts to ensure that we maintain the health of our critical freshwater resources. Thank you.
Next up, we have Karnig Estenssoro. Karnig's presentation is titled Shedding Light on Nocturnal Carnivores, How Artificial Light Affects the San Joaquin Kit Fox Behavior. Karnig's program is biology, and his advisor is Dr. Lucas Hall.
I don't know about you guys, but one of my favorite parts about living in Bakersfield is I always see these little foxes running around at night. These foxes are actually the San Joaquin kit fox, and they play many important roles in the natural desert ecosystem of the San Joaquin Valley, including playing both predator and prey. They're also nocturnal, meaning they're most active at night. Now, unfortunately, these foxes are considered endangered, which means the species of kit fox is at risk of becoming extinct. Yet they do surprisingly well surviving in our urban centers, despite it being drastically different from their natural environment. But why is this so surprising? Well, as humans, we alter our environment to do what we can to make our surroundings as comfortable for us through a process called urbanization. Additionally, as our population continues to increase, this process will continue to spread to other natural areas, completely altering the environment through a process called urban sprawl. This has been the case for the San Joaquin Valley for decades, with no sign of it slowing down. And unfortunately, the changes that we make do not always present the same benefits to the species that have lived in these areas before us. Now, the changes we set in our environment is extensive, but the focus of my study is the addition of artificial light and the increased presence of light pollution. While artificial light provides us with an extension of active hours, increased visibility, and additional safety, it imposes a new environmental stressor on these animals, and in most cases leads to a selection pressure that changes their physiology or behavior. In the case of nocturnal visual predators, they become more active in regions that are artificially lit, and these regions have an increased predation rate overall. Conversely, their nocturnal prey have a decreased activity in areas that are artificially lit. They spend more time in these natural hiding spots called refuges and less time foraging for food. Now, I mentioned previously that kit foxes act as both predator and prey. But how do these urban populations of foxes behave in the presence of artificial light? Are they bold predators or cautious prey? To study this, wildlife cameras that detect changes in motion and heat, like the one shown in the bottom left, will be set up in locations across Bakersfield. As you can see, each station will have cameras facing opposing sides, with bait set 2 meters in front of the cameras to lure the foxes. The only difference between the two directions is the presence of light. Solar lights will be used to eliminate the need to replace or recharge batteries, and differences in the time spent at each site and distance from the bait will be measures of indicators of behavioral variation. While artificial light and its effects on behavior is still new, it's becoming increasingly clear that light pollution affects more of the natural world than we previously thought. This project is currently in progress, so I can't speak on any of the results just yet. Though once complete, this research will allow us to establish more effective conservation efforts for the endangered San Joaquin kit fox. And additionally, understanding how this species alters its behavior in the presence of light may shed some light on how the species has become more successful in the urban environment. Thank you.
Next up, we have Manish Ghimire, and his title of his presentation is The Effects of Chronic Supplementation on Cardiovascular Function, Lower Body Strength, and Fall Risk in Older Adults. His program is Kinesiology, and his advisor is Dr. Kim.
Creatine supplementation is one of the very popular supplements in young adults to improve their strength and performance. And research data also supports that. However, there's inconsistent data with creatine supplementation without exercise in older adults. In older adults, there is presence of sarcopenia, which is a loss of strength and muscle mass. And that can increase the likelihood of fall risks and fall episodes. Additionally, vascular health is also reduced in older adults, and this can increase the risk of cardiovascular diseases. Current data with young adults and creatine supplementation have shown to improve vascular function. However, there is very scarce data on older adults. Therefore, in this study, we're planning to see how 30 days of creatine supplementation can impact vascular health, strength, and fall risk in older adults. In figure 2, we are measuring vascular health using arterial stiffness. It is the rigidity of the arteries, and we are using a gold standard method, non-invasive gold standard method, carotid femoral pulse wave velocity. In this method, we'll be using a pulse detecting tonometer on the neck and thigh cuff on the thigh to detect the pulse, and the number from this will give us pulse wave velocity, and higher number is indicating higher stiffness. In figure 3, we are using Biodex system to assess the strength on the leg. The participant would be sitting down and they'll be pressing against non-movable attachment, and this gives us how much force they are generating. Finally, with the strength, we are using another for hand grip strength. We're using the hand grip dynamometer. Participant would be sitting down and they'll be pressing it for 3 seconds, straight arms, and we'll measure those data. Finally, on the figure 5, we are measuring tug test, which is also known as timed up and go test, where participant would sit down and they'll be timed when they stand up, walk 3 meters, come back and sit down. Once they sit down, we measure the time. We'll do 3 trials for this as well, and higher time would be recorded. All of these measurements will be done at baseline and after 30 days of creatine supplementation. Currently, our research is still we're still collecting data, and hopefully from the results of this study, we're able to elucidate how creatine without exercise can impact arterial stiffness, measured by carotid femoral pulse wave velocity, and strength measurements, as well as fall risk assessments in older adults. Thank you.
And I will announce the runner-up and our winner. I just want to reiterate, the runner-up and the winner, they will have the opportunity to participate and compete in the 23 CSU campus-wide Grad Slam that will happen in the spring. Again, that will be hosted by CSU Long Beach. And then Our first place winner, you can see Daniela from last year, her trophy, will receive that trophy and have the opportunity to complete at the Western Association of Graduate Schools annual conference, which last year I believe was held in Portland. This year it's going to be held in Arizona, although it will be virtual. We have our top 2 finishers. I want to announce that our runner-up is Karnig. Let's give Karnig a round of applause. And our winner of the 2023 CSUB Grad Slam is Jonathan Juarez. And let's give him a round of applause. I want to thank all of you, all of the participants, all of the judges, the Graduate Student Center staff, the advisors for each of the participants in the different programs. I just want to thank all of you, the audience members, for being here today, supporting our students. Regardless if you won or were runner-up, I can tell you right now, everybody did an excellent job today. Very impressed by all the presentations, as always. So again, I want to thank everybody for being here today.